So in this video we are going to learn all about Zipkin distributed tracing server. So the question arises that why do we need a Zipkin distributed tracing server? So let's look at the problem first. We have this many microservices where each of the microservices is talking to one another. We have Eureka naming server, the Joule API gateway, the currency calculation service, the exchange service, and these are one way or the other talking to each other. In the real time, there can be hundreds of applications. Here it is only four. So what happens when a user makes a request and the request is not fulfilled? The application breaks there. So how do you find out where your application broke? What was the problem? Because we have so many different microservices, we cannot go to all the microservices one by one to find out where is the issue. So we have to implement a centralized logging where we can trace each of the requests and find out which request is failing. So here we are going to use a Spring Cloud Sleuth which will give a unique request ID to each of the requests. And that is, whenever a user makes any request, a unique request number is assigned to that request as it travels from currency calculation service to Joule API gateway to exchange service. It will be having a common ID which will be used to trace, and that will be assigned by the Spring Cloud Sleuth that we will be implementing in this video. So this is Spring Cloud Sleuth will be assigning this request ID, and all the logs from all of these microservices will be stored in a RabbitMQ, and we will be sending that logs to a Zipkin distributed tracing server. So I hope it will be clear why we need a Zipkin distributed server, so that we can trace each of the requests individually and we can have a common logging for our common goals. So let's start the implementation. So as you can see here that we have different applications and we have to identify which all applications we want to implement Spring Cloud Sleuth. We would be implementing it in Netflix Joule API Gateway, the currency exchange service and the currency calculation service. So how do we implement Spring Cloud Sleuth? So there is a dependency that we need to add in each of our application where we want to implement that. So the dependency that we have to use is Spring Cloud Starter Sleuth. Let's copy this and add it in our Joule API gateway pom.xml. We can go and add it here. Control A, Control I. That will format our pom.xml. Yes, save it and it will download the dependency for Sleuth. Now the other thing that we have to do in order to implement Sleuth in our application is we have to create a bean in our main application. Let's go to the main application, add this piece of code where we will be using the sampler and we will create a new bean. Let me import the bean dependency, the sampler that is coming from our Sleuth brave sampler, okay, and return. This is the default sampler. That means that we want to implement the Sleuth in all of the requests that is coming through this Joule API gateway. So we have to implement this default sampler dot always sample. So let's save it. The dependency that got important, you can see it here, and we have to implement the same thing in our currency exchange service pom.xml. We will add the dependency. In the dependency section, we will go and add the dependency. Similarly, we will do it in the currency calculation service. We will paste it here, Spring Cloud Sleuth, and we will also copy the bean from here and paste it in our main application of currency calculation and currency exchange. Let's save it, import the dependencies. That is still downloading the dependency, and we will do the same thing in currency exchange service application. Create the bean here. It's already imported because the dependency is downloaded. Okay, so the dependencies are downloaded and we have added in all the three applications. So one more thing we have noticed in our applications that we don't have much of the logs to see the changes that we have just made. So what we'll do, we are going to add some loggers using SLF4j logging. So how do you implement SLF4j logging? So let's go and implement SLF4j logging in our application. First of all, we will do it for currency exchange service. go to the controller, and below the class you have to write this statement logger, and this logger will be your slf4j logger. You have to import the slf4j, import the logger factory from slf4j, and the class name you have to give your current class name. So this is the logging that we are going to implement, and now we can go and use this logger anywhere in our application. So let me print this exchange value here, logger.info, and whatever you want to give it here. I will give this exchange value. This is the placeholder, and this value will come inside this placeholder. Let me organize the imports. So there are some errors. This is not our errors. This is a problem of Eclipse or STS. Sometimes it behaves like that. So let me refresh the project, and the errors are gone. Now we have this logger in place. Let's go and implement logger in our currency calculation service as well. Go to the controller, and here before returning we want to print this calculated amount. So first of all you have to give the logger statement in the beginning. You have to change the class name here, then use this variable to print your logger statement. We already have a logger in our Netflix Joule API gateway. Now to test this logging feature, we will start our applications in an organized manner. So first of all, we will start our Eureka naming server. Okay, so our naming service is started. Now we will start our Netflix Joule API gateway server. And after that, we can start any of it. We will start our currency calculation and currency exchange. And we will go to Eureka naming server port number 8761. So this is our Eureka naming server. It is showing that our Joule API gateway is already registered with naming server. Now let's wait for other two applications to start up. All our applications are up. Let's go to naming server and refresh it. So you can see these services are up. There are 3 instances of this one is up. That was not required. Anyway, we will stop the other two to reduce the load on my laptop. Okay. Now we'll go and test our currency exchange service. So the currency exchange, we will hit it through Joule API gateway. Let's go to hit our currency calculation service. Click on enter. So Hystrix read timeout Joule exception. After starting the Eureka naming server, we have to wait for a minute or two. It will make everything ready for us. So after refreshing, I can get this value now. Let's go to the logs and check what's happening here. Let me copy these statements and check in our editor. Let me clear the logs in here so that it won't be confusing for you. So this is a currency calculation service. Let me copy this, check it in our notepad. So this is the log of currency exchange service. Let me go to the log of Netflix Joule API gateway, and we will copy everything from here and keep it in our notepad. What I wanted to show here is that there is a unique ID generated by spring.sleuth, and that is across all the microservices. So if you see here, if I'm clicking on this number here, that is the unique ID, and you can see the same unique ID here. The one you are seeing it here is the previous request. Let me delete all that. Okay, so there is one unique ID here, and the same is through here as well in the Netflix Joule API gateway. So this unique ID generated by spring.sleuth is helping us to understand where our request is flowing through, which all microservices it is hitting, what are the output from there. If you see here, the exchange value that we gave here is coming in this one, and the request URL that is in our Joule API gateway, that is also getting printed. So if any problem occurs in our any of the microservices, we will be having the unique ID, and through that we can search that where the problem has occurred. For now, you see that our logs are coming into different windows of Spring Tool Suite. In the next video, we will implement the centralized logging so that all our logs will be coming at one place. So in the last session, we implemented the Spring Cloud Sleuth, which was able to generate a unique ID for each of our requests, and we were able to find out where all the request is flowing through, what are all the components involved. But there was only one problem that was associated with it, and that is we have to go to individual microservice to trace the logs. So that was the problem. Now in this video, we will be implementing a centralized logging system. All the logs from different microservices will be coming at one place, and it will be logged in an organized manner so that it will be very easy to understand for anybody. Okay, so there are so many providers of centralized logging. If you see, there is Kibana, there is a Splunk, and other providers are there where you can perform Elasticsearch and filter out the logs that you want based on different kind of string search. Now the question comes how we can implement that. We will implement that using Zipkin distributed tracing server, which will provide us a UI. But how do we push all our logs to Zipkin distributed tracing server? So we will use something called MQ, that is RabbitMQ, the messaging queue. We will put all our messages in the queue, and the Zipkin will be listening to this RabbitMQ. It will get all the logs and put it in an organized manner, and after that we'll be able to see the logs in one place. Basically, the Zipkin uses a database to store all the logs in one place, but our requirement is just to understand the concept. So we will be using H2 database, the in-memory database. Now in this video, we are going to start with the RabbitMQ installation. So all the links I have given down in the description. First of all, select the operating system that you are. Here I am using a 64-bit Windows system. So I will click on this link here, and Rabbit is an interdependent service. You need to have something called Erlang downloaded in your system before using RabbitMQ, otherwise it will not work. See here the dependencies. RabbitMQ requires a 64-bit supported version of Erlang for Windows to be installed, and you can obtain this Erlang from this website. Meanwhile, if you go to the RabbitMQ website, what are all the supported versions that is given here? If you are going to use a RabbitMQ with a version 3.8.1, you will have to install Erlang of version between 22.3 to 23.x. We'll be installing the latest version of Erlang from the website. So this is the official website of Erlang, and we will be going and installing this 23.0. Click on this link here, the 64-bit version of Windows, and we will click on start download. And meanwhile, go to the RabbitMQ website and click on the get started. After that, you will see this link, download plus installation. Click on that. Click on this link here, and you come down here. You will see this RabbitMQ server. Click on this download link, and it will start downloading this exe file as well. So both our things are getting downloaded. So now our both the softwares are downloaded. Now we will install each of it one by one. First of all, we will install the Erlang. It's pretty simple installation. Just click on next button. Keep everything to default. Okay, so the installation is complete for Erlang. Click on the close button. Now we'll install the RabbitMQ. Installation of both our Erlang and RabbitMQ is completed. How we can check if it is installed correctly? Click on, just type localhost colon the default port number for RabbitMQ. Default port is 15672. Click on enter. If you are getting this page, that means that your RabbitMQ is not yet started yet. Click on the start button, and after typing this command, your RabbitMQ will start. I will give this command in the description. Now let's click on the refresh button here. Now you will get this console. So here you need to provide guest and password as guest. That's a default username and password for RabbitMQ. So we have successfully installed our RabbitMQ in our local system. Now we have downloaded the RabbitMQ. The next step will be to download the Zipkin distributed tracing server jar file. So there is jar file that you have to download from the official website of Zipkins. Just go to the browser of your choice and type in Zipkin. Quick start. So this will take you to the Zipkin official website from where you can download the jar. After coming to Zipkin quick start, you will be getting so many methods to download the jar file. One of the method is by using the Docker. If you have already installed in your system, you can use this command to get the jar file. If you have a Java 8 or higher version installed in your system, the easiest way you can get the jar file by clicking on this link. If you want to use the source code of the Zipkin, then you can go to git bash and clone it using this command. After that, you can build the project by clean install command of mapping, and then you can start your jar file. But what we will do, we will just take the jar file from this link here. If you have Windows 8 or higher installed, the quickest way to get started is to fetch the latest release as a self-contained executable jar. When I click on this link, it will start downloading a jar file that will be around 60 MB. So our jar file is downloaded. I will keep it, and let's go to the location where it is downloaded. So it's here. I will keep that in a folder where it is easily accessible to me. Okay, so now we have got the jar file, and how we will run this jar file. So from here, let's go to the command prompt by typing in cmd in the address bar, and from here let's type java-jar and the jar file name .jar. Click on enter. So this will just run the jar file, and it will start the Zipkins. Once you get this, after that you have to go to a new browser and type in localhost :9411 Zipkin. Click on enter, and you will see something like this. So currently we don't have anything in the logs. So as of now, what we have done, we have just started this Zipkin distributed tracing server, but we have not connected this RabbitMQ to this Zipkins. In order to get the logs, we have to make this as a listener, because it will connect to this RabbitMQ and it will get the messages from the queue. So how we can connect this RabbitMQ? There is a command that we have to run. First of all, we have to cancel this, because we have simply started the Zipkin distributed tracing server, but we have not connected the MQ. Now we are going to connect the MQ. So for connecting the MQ, you have to give this command. If you are on Mac, you don't have to give this set. If you are on Windows, then you have to give this command: set rabbit URI equals to amqp :/localhost java -jar, and the jar file name. This jar file name we have to give, and then we have to press on enter. What we have done is, for this jar file we have set the RabbitMQ path as this one. So this Zipkin will be listening to this queue. For Zipkins to listen to RabbitMQ, we have to set a command that rabbit URI, we have to set it to amqp :/localhost. So this will set up a rabbit URI, and after that we have to run the command java-jar the jar file name. This time the Zipkin server will start, and it will listen to this URI. So it is started on port 9411. Let's go to port 9411, and you will not find anything in the trace here. because we have configured the RabbitMQ and we have configured the Zipkins to listen to RabbitMQ, but we have not configured our applications to send the messages to this RabbitMQ. So that's why we are not getting anything in the logs. So the next step will be to connect our microservices with the RabbitMQ. And the microservices to connect with RabbitMQ is currency calculation service, the currency exchange service, and the Joule API gateway server. So in order to connect that with the Rabbit, we need to have some dependency form.xml. And let's go to add those dependencies one by one. So we have opened the form.xml for currency service. So one of the dependency add will be for Spring Cloud Cloud Zipkin. Cloud Zipkin is basically to generate the logs in the format that Zipkin distributed tracing server is able to understand. And the next dependency is Spring Cloud bus AMQP. So AMQP is a protocol that we use for MQ for communicating or sending the messages. Save this. So cloud starter bus AMQP, and we will also add this dependency in our currency exchange service form, and similarly we will add that in Joule API gateway, so that message from all these will be to tracing server. So the progress. Now one more thing to notice here is that we have given these two dependencies and our Spring version here is 2.3.2. So this set of dependencies that we are using with the Zipkin, actually that might not even work with this version of the Spring, because we are using a version of a Spring that is less than 2.1, then these dependencies will be useful. But if you are using a higher version than 2.1, then these dependencies will not be useful and your Zipkin distributed tracing server will not even work. So what we have to do, we have to make one change here. Spring boot starter Zipkin. This is the new dependency that Spring has changed. Spring Cloud Starter Zipkin. And the second dependency here is Spring Rabbit. So let's save it, and this dependency is not taking because this is coming from AMQP. These are the weird ways, but what to do once Spring is changing, whatever the command Spring is giving, we have to follow that, otherwise our application won't work. So these dependencies we have to change it in all the three projects, the Joule API gateway as well, and in currency calculation service as well we have to change it. So we have made the changes and the dependencies are getting downloaded. So now we have done most of our changes and it's time to test our application now. So one by one we will be going to start all our applications. So we'll go to the boot dashboard, and first of all we will launch the Netflix Eureka name server, and we will wait for it to start. So you should start your services in a correct order. After that you can start the Joule API gateway server, and then you can start the currency exchange service. Then you can start the currency exchange service, and simultaneously you can start the currency calculation service as well. So now all our four services are up, and our Zipkin distributed tracing server is also up, and the MQ is also running in the background. Let's make sure that everything whatever we have said is up and running. Eureka, let's refresh it. So the Eureka is running with all these three services. Now our MQ is running in the background. The Zipkin, so our Zipkin is also up and running. So this is our RabbitMQ management console. Now let's test one of our services. Let me click on the refresh button. So it's timeout. This will usually come because we have just started the Eureka naming server. Will take some time to register all the services. So now it's giving a correct response. So now if you come here and see that in the last 5 minutes in the Zipkin we have got these two logs here where the trace ID will be this one. It is intercepted by Joule API Gateway Server where we have got the logs for this trace ID. Let's hit it once again and query blank query. I've hit it again, got the log few seconds ago, and this is the trace ID and where all the request has gone through. That is also populated here. Our main task was to handle the centralized logging. We've done it using Zipkin distributed tree. Have a look at all of this and figure out what all the things do. So our goal has been established. We are able to send the logs to Zipkin server. So this was our main goal. So thanks for watching. We will see you in next video where we will discuss about fault tolerance and historics.